We know that the reconfiguration time can have some negative impact on the final solution latency. But being able to adapt the system at runtime is such a huge possibility that we do definitely have to find a way to deal with such an overhead. To do this, several solutions have been studied and proposed over the years. We can summarize them as in the following. First, reducing the bitstream dimension, hiding the reconfiguration time, maximizing the reuse of already configured modules, exploring alternative implementation, maybe software execution, or finally, exploiting a better area usage by using bitstream relocation. Before digging into the details of each one of these techniques, let us just briefly introduce them, trying also to extract common characteristics whenever possible. Let's start from the very beginning, reducing the bitstream dimension. This is a trivial observation. We know that reconfiguring an FPGA means to properly store the configuration bits on the configuration memory. Now, within this context, it's trivial to notice that the reconfiguration time is the time spent in saving the content into the configuration memory. That means that the reconfiguration time is proportional to the amount of data that has to be stored, which means that the bigger the configuration bitstream is, the longer it takes to store it. Therefore, it can be easily understood why reducing the bitstream dimension will positively impact on the reconfiguration time. There are several ways in which this can be done. One of the more widely used is by compressing a bitstream during its generation and by adding a decompression core on the FPGA. It is also interesting to notice that there are at least a couple of solutions that are exploring techniques that are trying not to use the reconfiguration at all. These two are maximizing the reuse of already configured modules, exploring alternative implementations. This is definitely interesting because what we are doing here, it is not to try to sell the reconfiguration per se, but in demonstrating the benefits in using FPGA-based solutions to implement your system, and in doing this by exploring all different opportunities provided by these devices. An FPGA is a device that is going to provide resources that are going to be configured to implement the desired logic. This means that you can play during the design space exploration of your system with several alternatives. You may be interested in implementing a softcore and in having your application executed in software on it. Or you may want to have everything implemented in hardware. And in doing this, you may be interested in extracting isomorphic structures from your system specification to be implemented as hardware modules. We may also provide a different way of reading, combining our techniques. We can consider hiding the reconfiguration times and exploring alternative implementation as a way to have a closer cooperation between the design time and the runtime. Hiding the reconfiguration times means that we have to carefully identify at design time portion of the system that will be later on used by the runtime to hide the reconfiguration by calling them wherever it will be more convenient. Exploring alternative implementation is by definition an integration of the decision taken at design time with the runtime. We cannot, at runtime, explore alternative implementation based on the runtime condition if we do not have alternative implementation that can be explored.